Today we will start with the fourth chapter of your syllabus, surface chemistry. So first we will start with the term, what is the meaning of surface chemistry here? So surface chemistry is the branch of science that deals with the study of phenomena occurring over the surface or interface. The branch of science which deals with the study of phenomena occurring over the surface or interface. So here, what is surface or interface? We can say boundary of separation between two different phases. If there are two different phases, then the boundary that separates the two, that is called as the surface, or we can say interface. So here I can draw like this. If this is the solid and we keep this solid in contact with the air, or we can say any gas, so these are the molecules of the gas and this is the solid. So this boundary of separation, this is called as the surface. Similarly, we can take another example to understand the surface or interface. If we have a beaker and we add two liquids into it, so if these two liquids are immiscible, for example, we have added oil, so this is oil and this is the separation and this is water. Suppose we have two liquids, one is oil and other is water. So if we mix them together, then this boundary of separation between the two, one is oil and other is water, this is called as the interface. So all those phenomena which occur over the surface of a substance, or we can say over the interface between the two phases, between the two substances, then all these phenomena are studied under the branch of chemistry called as the surface chemistry. So we will start with the first phenomena in your syllabus related to surface chemistry, that is adsorption. So here we will first start with the adsorption. So what is the adsorption? If we keep a solid substance in a container in which we have stored a gas, here it is the solid and we have added the gas to this chamber. With the passage of time, what we see, these molecules of the gas, first these are attracted by this solid surface toward it, then slowly these gas molecules get retained over its surface, or we can say there is the formation of a layer over the surface of solid. This formation of this layer occurs due to the adsorption. So how we can define adsorption? It is defined as the phenomenon of attracting and retaining molecules of a substance over the surface of another substance. So we can say, if in a phenomenon the molecules of one substance get retained over the surface of another, it is called as adsorption. We can take different examples from the day-to-day life. For example, if we have a piece of wood here and we apply paint over its surface, this is wood, and we apply paint over its surface, then we see when we apply paint over its surface, the molecules of the paint get retained over the surface of wood. They don't go inside the bulk of the wood. We can say a layer of the paint molecule is formed over the surface of wood. Then this is also another example of adsorption. Similarly, there are so many phenomena in our surrounding which are occurring, and all these are related to adsorption, and we will discuss further more examples related to adsorption in the later part of the chapter. And here I am going to start with another term related to the adsorption, and this term is, for this adsorption, two substances are interacting with one another. The molecules of one substance are retaining over the surface of another. The substance over the surface of which molecules are retained, this is called as adsorbent, while the substance whose molecule get retained over the surface of another substance, this is called as adsorbate. So in this example, we have taken gas and a solid substance. The molecules of the gas form a layer over the surface of solid. So these molecules of the gas, they are acting as adsorbate, while the solid substance is acting as adsorbent. So how we can define these? So first is adsorbent. The substance, we can define in number of ways. The substance over the surface of which adsorption occurs. Adsorption occurs. Similarly, we can say the substance which attracts or retains molecules of another substance over its surface. So we can define in two ways. The substance over the surface of which adsorption occurs, that is called as adsorbent. Similarly, we can define it in another way also. The substance which attracts and retains the molecules of another substance over its surface. So this is also called as adsorbent. Similarly, we can define adsorbate. So what is adsorbate? The substance whose molecules get retained over the surface of adsorbent is called as adsorbate. The substance whose molecules get retained over the surface of adsorbent is called as adsorbate. So adsorbate and adsorbent both are involved in this phenomena, only then adsorption occurs. So further we will discuss about these. Adsorbate can be a gas or it can be a liquid, but it can never be a solid. Adsorbate can be a gas or a liquid, but it can never be a solid. In the same way, if we talk about adsorbent, so adsorbent can be a solid or a liquid, but it can never be a gas, because gas has no surface. So adsorbent is a substance which provides a surface for the occurrence of the adsorption. So for the occurrence of adsorption, there must be a surface, only then the molecule of another get retained. So gas can't act as adsorbent. In the same way, a solid can't act as adsorbate. Then further few examples of further few special cases of adsorption are there, and out of these, one is occlusion. So what is occlusion? It's a special case of adsorption. What is special about this? We can call adsorption as occlusion if adsorbate is a gas while adsorbent is a metal. So we can say if the adsorption of a gas occurs over the surface of a metal, then adsorption is called as, if adsorption of a gas occurs over the surface of a metal, then it is called as occlusion. Then it is called as occlusion. So we can say occlusion is a special case of adsorption when we use selective adsorbate and adsorbent. Similarly, there is another term related to this phenomenon of adsorption, and this another term is desorption. So as it is clear from its name, the reverse of adsorption is called as desorption. Or we can say the phenomenon of removing the molecules of adsorbate from the surface of adsorbent is called as desorption. We can say if we have a solid over its surface, there is a deposition of adsorbate molecules. So this is adsorbate and this is adsorbent. if we heat this, or sometimes we can say we rub the surface of adsorbent, then what is the observation? We observe that the molecules of adsorbate starts leaving the surface. They start escaping from the surface. They move away from the surface because of heating. Their kinetic energy increases. Of the molecules gain energy from the heat, and their kinetic energy increases, and they move away from the surface, or we can say desorption occurs. Desorption occurs. I will also discuss one thing more related to adsorption, and this is a particular observation. Sometimes we call it as we observe a phenomenon in which we become confused then whether this is adsorption or something else, that is we can say absorption. So in that case we use the term Yorkshire only, because this is related to another surface phenomena, that is absorption. We will discuss this later, then we will discuss here about absorption. There is another phenomena, sometimes adsorption can also change to the absorption. In that case we use Yorkshire. We will discuss about this little bit later. So here I am giving you the detail of adsorption. So further we are going to study what is the cause of adsorption. Cause of adsorption. So why there is attraction and why there is the retaining of the molecules of a substance over the surface of another, and we are going to have its cause, the reason behind this. What is the reason behind this? We are going to discuss this. We have already studied in class +1, that is about a phenomenon called as surface tension. So if you know about surface tension, then with the help of this concept we can also have the concept that is adsorption. So how this is related to one another we can discuss here. First, I think you must know about surface tension. We know in a liquid, here we have a liquid in a container. What we observe in case of liquid? We see that this is the surface of liquid and molecules are lying close to the surface, as well as the molecules are present in the bulk of the liquid. We know that this is the molecule, for example, this is the molecule. If we study the net force of attraction over this molecule is equally attracted by surrounding molecules in all the directions. This molecule is attracted toward this direction, toward that upper side and lower side, because all the molecules are of similar type. Hence, the force of attraction in all the direction that will be same with respect to the magnitude. So, if we observe, then net force of attraction over this molecule, it will be equal to 0, because the force exerted by this molecule is balanced by this. In the same way, the force exerted by the downward molecule is balanced by the upper side molecule. Now, what is special with reference to these molecules which are lying close to the surface? We see that the molecules which are present close to the surface, these are pulled downward by the molecule lying exactly in the lower layer. And there is not any molecule above the surface. There can be vapors, but Vapors can't balance the force of attraction because in the vapor phase there will be very few molecules as compared to the molecule present in the bulk. In general, we can say the molecules which are lying close to the surface, these are pulled downward. There is not any molecule which can balance this downward pull above the surface. So, as there is not any molecule above the surface, so what we observe here, the molecules are pulled downward, due to which the surface becomes curved. So this is the cause of surface tension. This we have studied in case of surface tension in class +1, that the surface becomes curved due to the net force of attraction by the molecules present below the molecule lying close to the surface. Hence, the surface appears a curve like, due to which we say surface is appearing as it is in tension. So we say it is surface tension. So in the same way, in case of solid, we know solids have specific boundaries, they are rigid in shape. The molecules which are present close to the surface, they are in different atmosphere than the molecule present in the bulk of the solid. This is the molecule present in the bulk of the solid. There is net zero force over this molecule, zero force of attraction, because this molecule is equally attracted by the surrounding molecule with same force in all the directions. But the molecules which are present close to the surface, they are pulled downward by the lower layer molecule. So due to this, as there is not any molecule above the surface which can balance this downward pull, so over the surface of solid, we can say there are some unbalanced forces. There are some unbalanced forces present over the surface of solid. So these unbalanced forces are the cause of adsorption. These are responsible for attracting and retaining the molecules of adsorbate over the surface of the solid, which is acting as adsorbent. Or we can say when this solid surface with unbalanced forces comes in contact with the molecules of a liquid, or we can say a gas, to which both we are called as adsorbate. Adsorbate can be a liquid or it can be a gas. When the molecules of the liquid or gas acting as adsorbate come in contact with the solid acting as adsorbent, these unbalanced forces which are present over its surface, they attract these molecules and they retain these molecules over their surface. This is how the adsorption occurs. Then how many molecules will get adsorbed, will get retained, until we can say the molecule will get retained over the surface of solid until the value of all these unbalanced forces become equal to 0. When the net unbalanced forces become 0, the adsorption stops. So rate of adsorption we will study further. This will depend upon the nature, or we can say value of the unbalanced forces present over the surface of adsorbent. So more is the magnitude of unbalanced forces over the surface of adsorbent, more faster is the rate of adsorption, more firmly the molecule of the adsorbate will get adsorbed over the adsorbent. So this is the cause of adsorbent. So we can say over the surface of adsorbent, the molecule are lying in a different atmosphere than the molecule present in the bulk of the adsorbent. So because of this difference in the surrounding, there are present unbalanced forces over the surface of the solid. So these unbalanced forces are responsible for the phenomenon of adsorption. So with this we have studied the cause of adsorption. What is the cause of adsorption? We have covered up to this. Then further we will study about the another nature of this phenomenon, that is when adsorption occurs. This is the observation that it is exothermic in nature. Adsorption is exothermic in nature. This we have already studied in class +1 in the thermodynamics chapter, in the thermochemical reaction or processes. Any process which occur with the release of heat is called as exothermic process. In the same way, adsorption, when adsorption occurs, there is the release of some energy in the form of heat. Energy is released, due to which we call it as exothermic in nature. So here we will prove that why adsorption is exothermic. So there are two ways to explain this. One is very simple. This is based upon the concepts related to the states of matter. You can say this is the adsorbent, that is the solid with some unbalanced forces over its surface. And here we have a gas acting as adsorbate, and this we have already studied in case of the chapter states of matter in +1. We know the molecules of the gas are in random motion. Random motion means we can say they have high kinetic energy. The molecules of the gas are moving randomly. They have a lot of energy with which they are moving toward different directions. So they have high kinetic energy. This is when they are not retained over the adsorbent. They are moving randomly before the adsorption. But when they come in contact with the surface of adsorbent, these molecules are attracted by the surface and they get retained here. So this is a general logic that when these molecules get retained here, there must be loss of kinetic energy, because before adsorption they were moving randomly, but after adsorption they get retained over the surface. So now they get retained, their motion, we can say randomness, has decreased. So because their motion or randomness now has decreased, then we can say they have lost some energy. So this energy which they have lost, this lost energy comes out in the form of heat. So due to this we can call as we can say adsorption is exothermic. Then this is the first way that I have explained that why adsorption is exothermic in nature. Then there is another way by which we can also explain that why adsorption is exothermic in nature, and this second way is you must know about the basics of thermodynamics. If you know the basics of thermodynamics, you can easily follow this. You can easily got the concept of exothermic nature of adsorption. And what is this? We know adsorption is a a spontaneous process. We know that what type of the processes can be called as spontaneous? The processes which we can say the process which can occur itself or upon little initiation. And from the concepts of spontaneity, there is a most accepted concept, that is the Gibbs free energy. We know for a spontaneous process delta G is always negative. According to the criteria of the spontaneity, any process which is occurring spontaneously, it must have delta G value equal to negative. So as adsorption is a spontaneous process, that is when the molecule of adsorbate come in contact with adsorbent, spontaneously adsorption occurs. So we say adsorption is also a spontaneous process. Further, we know from Gibbs free energy equation. This is also called as Gibbs-Helmholtz equation. That is delta G is equal to delta H minus T delta S. So in this equation, delta H is the enthalpy change, delta S is the entropy change. We have already derived this equation in class +1. So this is the equation from which we can explain the spontaneity. So for a spontaneous process, delta G is negative. We have already studied here. Then from Gibbs-Helmholtz equation, we know delta G is related to delta H and delta S by this equation. Further, one more observation is there. When adsorption occurs, first, before the adsorption, gas is moving randomly. But when it gets retained, we say randomness decreases. So this is one more observation from the phenomenon of adsorption, that when adsorption occurs, it is accompanied by decrease in entropy of the system. That is, randomness decreases. Before adsorption, molecules of the adsorbate, that is the gas, were moving randomly here and there in all the directions. But when they get retained, their motion decreases, randomness decreases. So as entropy is the measure of randomness, we say entropy decreases. So delta S is equal to negative for adsorption. So we have determined these two values, delta G is negative, delta S is negative. So if we put these values, we say delta G can be negative. How it can be negative? You can have idea from this equation. I have put this value delta S negative here. Then delta G can be negative. So from this equation we can say delta G can be negative only if delta H is negative. First point. And second, if delta H is negative but as well as it is greater than T delta S, so that if we put these values, delta G will come out negative if delta H is negative. When the cancellation of these two occurs, if delta H is greater in magnitude than T delta S, only then the delta G can be negative. So we say delta G comes out negative only if delta H is negative, and hence any process for which the value of delta H is negative, it is exothermic in nature. We have already studied in class +1. So here we will say that adsorption is an exothermic process. I have explained this in two ways. This is the second way or this is the first way. With this we have completed what is the adsorption and terms related to the adsorption. What are adsorbate and adsorbent? The cause of adsorption we have already studied here in this session, and we have also discussed the exothermic nature of adsorption. Then we will further discuss more about adsorption and absorption and its difference with the absorption in the later session in the next class. Thank you.